Welcome to Digital Dialogs, your compact conversations on the future of technology. My name is Rene from Reply, and today we're going to talk about neurally inspired design and bridging emotion and technology. Sounds like an awesome topic, and I'm very honored to have an awesome special expert guest today, Professore Alberto Gallace. Ciao Alberto, come stai?
Hi, everyone. Yeah, I'm fine. I'm okay. Good.
Hey, awesome. Well, thanks for joining us today. I would ask you to tell us a bit about yourself and as your background relates to anything, the research you're doing, the neuroscience, and all of these things. Please introduce yourself.
Yeah, sure. Basically, I'm the current director of a research center, an excellence research center that is in Milan at University of Milano Bicocca. It's called the MIPTEC, Mind and Behavior Technological Center. And basically, the research activity that we do in this center is based on the relationship between humans and technology. We try to understand how human works from the point of view of psychology, cognitive neuroscience, linguistic, and so on, and use this kind of information to create better technology, better application, and so on. So we work at the interaction between humans and technology. And my background is basically in cognitive neuroscience and multisensory information processing. So that's the reason why I work on that kind of field.
Well, that's an impressive background for sure. And so given your extensive research and multisensory integration background and the research you're doing in that field of multisensory integration, the sense of touch and so on, how do you see these elements enhancing virtual environments and human-computer interactions to evoke, more emotional and behavioral responses?
Yeah, basically, if you look at the way in which the brain works, you immediately see that it is a multisensory machine. Basically, we don't just process a single sensory modality independently from the contextual information, so from all the other sensory modalities that are there at any one time. So basically, we integrate information, and the brain is able to perform in a more efficient way every time we do this kind of integration. Basically, from a neural point of view, we have these neurons that are multisensory in nature. So when you send a signal from a multi-sensory modality, so let's say vision, and that signal is alone, it generates a response from that neurons. But when you present a vision together with audition, together with touch, the very same neurons has a much higher level of response. And that mechanism is built as a function of our improvement. So in order to improve performance, in order to create better emotional responses and so on. So by understanding how these mechanisms work, we can create better experiences and enhance human performance. Because again, imagine a virtual environment that is only visual, right? That is not enough in order to create that level of experience that is needed to perform in the most efficient way. So we need to understand the ingredients that the brain uses in order to produce experience, emotions, and perform in a more efficient way. And that's why we need to understand this process of multisensory integration in order to create more efficient environments.
Absolutely, I fully agree. And also my background is not only AI and effective computing, but also quite a bit about immersive experiences, and that's super interesting. Also, when it comes to like you're saying, the multisensory kind of support for these experiences. And what you definitely noticed is, when we're talking about a VR experience, for example, right? Like you have very good 3D visuals already with stereo 3D. So that's one sensor element. Then you have the second, you have spatial sound, like, sound that you can hear and locate in the room. So we also have that solved, right? And then we're entering the space of, okay, we're getting also touch simulation with haptic feedback devices. For your hands and, with some devices also for the body to a certain extent, obviously. But there's so much more, right? Humans also have smell, for example. And I engage with a company that produces these virtual scent, virtual smell, but it's of course very hard to make that a reality because of all the different variations we have with smell, but also temperature, What else do we have? Like, it's all so much, right? And all of it has to come together to provide a very good immersive experience. What are the frontiers you're seeing in terms of what are the hardest sensories we should what are the hardest to simulate sensories that we have to support in order to make a truly believable experience?
Yeah, you are completely correct in saying that we have many different experiences. Most of the people often think about vision, audition, and touch, but we have much more than that. Basically, also olfaction and proprioception. For example, proprioception is the perception of the strength generated by your muscles. Let's say that I try to lift an object, right? And I measure the weight of that object, and my body adapts to that weight. We adapt the way in which we perform with the object as a function of this proprioceptive information that is coming from the body, the feeling that we are moving, the feeling that we are lifting weights, and so on. So that is very important for our ability to interact with the world. And plus, you mentioned olfaction, extremely important, but not so easy to be reproduced in virtual reality. Certainly, another sense that is not absolutely easy to reproduce is the vestibular stimulation. So the stimulation of your inner ear that produce the sense of acceleration, deceleration. For example, this is extremely important in driving simulations, right? Or all the simulation where you have to run, to do an activity that is related in some way to a fast movement of your body. This feeling of moving, of changing the position of the body, of accelerating, reducing your velocity, and so on, is produced by the vestibular system. But I guess one of the most, or probably the key, what is considered very often the holy grail of virtual reality is the reproduction of physical contact with objects, so the tactile simulation. Because if you think about it, every time we interact with the world, we perceive the reality of that interaction based on our physical contact with the world. So if I'm not sure if something is real or not, what I do, I raise my hands and I try to touch it. If I touch it and I get some sensory feedback from that information, I realize that that's real. That's in front of me. It is something in my hand and so on. And the same is true for my body. If I have a body, I can embody in something, in an avatar or something in virtual reality. But it's in the moment in which my body touch another object, interact with another object in a physical way that I truly perceive that that's me, and that's the boundary of my body are actually related to the sense of touch. Touch is something that I'm used to say, create the boundaries of your body. So you perceive that it's your own body based also on that sensory modality. This is why it's so important. And not only for that, it's also important for the emotional contents of our experience. It's probably even more important in that kind of field.
Yeah, it's a very, very good point. And on that note, so how can neuroscience help basically when we understand all the different also emotional states, for example, the pleasure and pain and so on? How does this then all that knowledge that comes from neuroscience inform the design of emotionally intelligent AI systems? Particularly, I'm interested in when we want to create systems that resonate on a deep emotional level with users, because sensor is great, we can simulate it, but what about also, let's say, an NPC or some kind of avatar or whatever, like an AI-driven one that needs to connect emotionally and provide good, effective computing capabilities. So how does also neuroscience help to drive these kind of systems?
Yeah, basically, neuroscience offer many different hints about what needs to be reproduced, how to reproduce it, and how to generate a specific emotion. I just make an example. We were talking about touch and the strong role of touch in generating social emotions, so interaction, affection, and stuff like that. From a neural point of view, we understood that we have a system that is entirely dedicated to create this emotional value of touch. Is based on a specific class of fibers in the skin that are called the CT fibers, and they respond for stimuli that are like caress. So if you move a stimulus across certain parts of the body, you generate a pleasant sensation that is totally driven by that separate system. It's not the same system that we use to recognize the object when we touch them. It's based on the idea that we are social beings, and so we need that kind of stimulation in order to bond together, in order to stay well together, and so on. So understanding this mechanism allow you to recreate that kind of emotions, and plus any kind of human relationship from a social point of view is based on emotions. We need to understand what an emotion is. Many people think that emotions are just a sort of simple response that we have for the external stimulus. But that's much more complex. What I mean with that, for example, we also interpret the value of certain stimuli in the environments, and we generate emotion accordingly. For example, I generate a physiological response in a given situation, so my heart beat faster or my skin start to sweat more, and not only that is an hint that I fear something, for example. So emotion and physiological response. But my interpretation of that physiological response could change as a function of the contextual information that is presented. So I can interpret that rise in heartbeat, that rise in the sweating of the skin as pleasure or rather fear. So it's different. I can feel that that is a hint that says I'm in love with someone, or rather I fear someone or a certain situation. It's the same physiological reaction, but is interpreted differently by the brain. And that's not easy, of course, because you need to understand the mechanism that occurs during also this complex interpretation of physiological reaction. So emotions are very complex from the point of view of neuroscience, but by understanding how the brain generates them, you can try to have the right situation that produce that kind of emotion, that kind of response in humans.
Well, that's fascinating. And also the aspect I think is interesting when it comes to different emotions and stronger, I would say, physiological responses, right? You mentioned, like, for example, if I'm afraid, if I'm, fearful or something, like I start to sweat, maybe if it's a very strong emotion. And my question would be, like, are there certain emotions that trigger stronger physical responses? Is that already known? And so how can I leverage it when I, for example, build a kind of a companion, like an AI-driven companion, like let's say an avatar, to use it in a good way to drive good user behavior? Is that already in the works, or what can you say about that?
Yeah, in terms of strength of emotion, there are the basic emotions, fear, anger, happiness, that are kind of easy to detect, and they can generate a very strong reaction from user, also from a physiological point of view. So you can detect something and you can infer that there is a change in the status of the user and the status of the human in response to a stimulus. There are other emotions that are more subtle, right? And so guilt, for example, imagine the emotion of guilt, be guilty for something that you did. That is much more difficult to understand. It's much more difficult to cope with that. It's much more difficult to find a physiological correlates of that emotion, right? So here we are in a field where the interpretation of the signal that generate that kind of emotion is more complex. So for some emotion, it's easier to have a selection of the stimuli that generate that emotion. And so you can anticipate, you can predict, and so on. For some other emotion, it's much more difficult because they are more complex. They are determined not only by physiological responses, but also for more complex cognitive abilities and so on. So there are different level of complexity. And for something, we already have many data about, and for something else, we still need to do a lot of research in order to understand the phenomena.
Yeah, understand. And the emotion detection, what we're also currently working on is obviously with effective computing, with the digital humans that we're building, to also have effective computing responses to also analyze the emotional state of the user. But one topic, and I think that also goes a little bit into the direction, is the mood, right? The mood of a person. Like my emotional state right now, I can detect it with a system, right? But detecting the mood of a person, which is on the longer, I would say, time horizon, right? It's more temporal information. That is very hard to detect with AI systems, but it's a very important aspect, right? The mood of the day can drive a lot of different decisions. So, yeah, curious what you think about that.
Absolutely, I do agree. Detecting the mood is probably one of the most difficult things. You can predict what kind of mood you could be in that situation, but it's difficult to be completely sure about it, because even if you collect a lot of physiological reaction, not necessarily that physiological or behavioral reaction are totally correct in the interpretation that they can provide, right? Because it's more difficult. Probably we need much more signals in order to have a correct interpretation for that parameters. And plus, like you said, it's something that occurs in the long time, for a long period of time. It's not just stimulus reaction and that's it. So physiological reaction or a behavioral reaction to a certain stimulus that you can control. The mood is determined by many different things. I slept well or not during the night, and then that translates into a good or bad mood. Today there is the sun or not, or maybe there is the sun. I planned a trip somewhere, and so I have a good mood. Or there is the sun, I have to go to work. The same stimulus, the presence of the sun, is interpreted and produce a bad mood because I have to work and I cannot go outside for a trip or something like that. So many different aspects affect the mood. And so that's why it's difficult to predict it. It's difficult to generate situations that produce a certain mood by the human participant.
Gotcha. That makes a lot of sense. And my final question would be, you're a strong believer when I look at your LinkedIn site. By the way, folks, you should connect with Alberto on LinkedIn. Awesome stuff. But you're also a strong believer in neurally inspired design. And so how do you envision the future of technology and design in creating these multisensory experiences that actually have to fulfill desires and needs of humans? Like, while we also got to make sure we maintain ethical principles and human rights, right? I mean, we can do a lot also with the understanding of effective computing and so on, but that can also be abused in a sense of, right? So the better we get in adhering to and connecting with human sensors, that also, of course, raises the questions like, how can we make sure this is used in an ethical and responsible way?
Yeah, it's a very interesting question, because we struggle very often in trying to envision a future where the ethical aspects are strongly considered and are actually at the very foundation of technology design. That's the most important thing, because we can understand how the brain works. We can create a situation where you generate desire, you generate emotion, you generate behaviors. The real problem is that is exactly what you need. What do you mean with that? Imagine, let's talk about the movie, The Matrix. You know the movie, probably, if you are interested. In The Matrix, you reproduce everything correctly in the right way, right? Sensory stimulation, physiological reaction, proprioceptive information, everything is simulated perfectly. So you generate the desire, you generate emotion, you generate everything. However, there is total control of human based on that. And that's exactly what we want to avoid. Virtual reality and simulation should try and not only to reproduce a desire, feeling, and stuff like that, but also to generate what is proper of humans, creativity, the possibility to do different things, to generate alternative thinking and stuff like that. That should be one element at the very base of ethical design. So you can inspire to the functioning of human mind. You can understand the principle of functioning of the brain and generate very good simulation, very good interaction with technology and so on. But these kind of interaction should be based on the idea that we need freedom. We need to have your own control. You need to take your decision. If you force people, and it's normal also to force from a computational point of view, because again, creating novelty means to create infinite possible alternative and that produce a computational problem, right? Because creating infinite number of alternatives means to have an infinite computation capability. So very often what you do is to just offer a limited number of options, and people choose between the option. The option can be perfect from the neural point of view because they generate certain reaction and so on, but are just limited. The real struggle, the real battle is to create as many options as possible in order to favor creativity. That is the main aspects of the human being, the possibility to think alternative and stuff like that. In our laboratory, for example, we have experiments where we use virtual reality to try and favor creative thinking, using, for example, four-dimensional environments that cannot be experienced in the real world to see if people generate creative thinking after they are exposed to that kind of simulation. That's the idea. So understanding the human brain allowed to create better simulation, but you need to understand also what drives the brain in terms of human beings. That is creativity, is this kind of activity that is unique for us as a species.
Awesome. Well, these are some really good insights here. Unfortunately, we're already at the end of the show for our podcast here, which we want to keep short and on point. And that's what you did, Alberto. So thank you so much for joining us today and sharing your impressive insights. That was very much appreciated.
Thank you very much. Thank you very much. And feel free to see our website and check our research.
Absolutely, folks. You heard it. Check it out. And thanks, everyone, for joining us for Digital Dialogs, your compact conversations on the future of tech. Watch our blog, follow our social media, and subscribe to our Reply podcast channels on your favorite podcast platforms to not miss the next episodes. And of course, you can listen to all the previous episodes and also our amazing other podcasts anytime at reply.com. With that, I say thanks a lot, take care, and see you soon. Bye-bye.